180 years ago, a British naturalist by the name of Charles Darwin set sail from his homeland of England on a ship called the HMS Beagle. The 5-year voyage and the various stops on that voyage inspired Darwin to make, from his own mind, a theory which would become one of the most fundamental theories of all time, the theory of evolution. Throughout Darwin's voyage, he made a great number of stops, but the most famous of which is that of the Galapagos Islands, a chain located off the coast of South America. What he found there was incredible. A huge variety of creatures lived in that region, and some varied from island to island. Tortoises as large as he was lived in the area, and Darwin wondered what caused all of these differences. He came up with the theory of adaptation, or the theory that organisms change over generations to fit their environment. But enough talk here. Let's actually go to the Galapagos. Oh, whoa! We're finally at the Galapagos. Anyway, these islands are very fertile and absolutely full of plant and animal life. Oh look! There's a creature right here. This animal is a marine iguana. They are similar to their land cousins, but, well, are marine. Unlike their brighter-colored South American relatives, these animals have longer claws to get a grip on slippery rocks. They eat seaweed, while their land-bound relatives eat fruit and climb trees. But what causes these differences? Scientists use the theory of geographic isolation to explain this. According to this theory, a group of iguanas became isolated some millions of years ago. Presented with a new environment and food sources, they slowly adapted to the habitat. This was, in the scientists' opinions, illustrated by natural selection, the process by which the animals most well-suited to an environment live and reproduce, while the unsuited ones die off. Another name for this theory is the survival of the fittest. Well, there are a number of other theories that help to explain the theory of evolution. One of them is the fossil record. While it in itself is not necessarily a theory, scientists use it to see the number of items and things in a particular layer of rock. And how they date that I'll tell you in a minute, but let's go to an excavation site. Well, there are a number of other theories that help to explain the theory of evolution. One of them is the fossil record. While it in itself is not necessarily a theory, scientists use it to see the number of items and things in a particular layer of rock. And how they date that I'll tell you in a minute, but let's go to an excavation site. The fossil record is how scientists date fossils. In places like the one behind me, you can see the different layers of rock. Much like a stack of books or a stack of paper, the ones on the bottom are the ones that were first put there. The ones on the top are the youngest. This is a method used to compare ages relatively. It can be used for rocks, fossils, just to see which one was put there first. So, it's called relative dating, not like inbreeding. For example, a fossil found in a layer down here is older than a fossil found in a layer up here. Now, on to absolute dating. Absolute dating is dating an object with an actual number. Scientists use machines to measure the amount of radioactive elements in a substance. Then, they refer to a chart and give it a possible age. They were able to do this because each radio element has a half-life, or the time it takes for half of that element to decay, or turn into another substance. By referring to the time period for each element, scientists can slap a date on a fossil. Speaking of fossils, let's have a look at the different types. A fossil, by definition, is the preserved remains of an organism from long ago. However, fossils can come in many forms. The first is that of the ice monkey. In this type of preservation, the organism's carcass becomes encased in ice, prevented from decay by sub-zero temperatures. Bones, flesh, teeth, hair, and skin are all preserved. The second type is being preserved in amber. Amber is a stone formed from the sap of ancient trees. An insect or other small organism became stuck into resin and was encased, preserving the body. The third and fourth types of fossilization are that of petrification, where an organism is replaced by minerals over time, or good old-fashioned mold and cast fossils, where the old body dissolves underground and leaves a hollow mold, which is then filled with minerals, making a stone copy of the original. In conclusion, I would like to thank you for watching this presentation, and make sure that you know science, because this is Science with Connor.